Good morning. It's 9 o'clock Wednesday morning, and we're getting a soft, gentle rain right now, although I just received a flash flood warning. I can't imagine it flooding right here because the rain is so gentle, but flash floods don't depend upon what the weather's doing right now. It depends more on what it's done in the recent past. Let's leave that alone and do some calculus. This material is from your textbook, page 163, section 2.7. It's going to be essential that you're reading your textbook and studying from your textbook as you go through the course. And there are lots of unassigned problems in your textbook, but they're very good practice problems. And the answers for half of those problems are in the back of your book. And there are problems in the text of your book that are followed by complete solutions to the problems. So those are also very good for study and practice. Now let's think about marginal analysis, a new topic, but this topic is very closely related to the previous topic, which was differentials. We'll see how that is in just a second. Suppose that we produce fashion watches, and that at a production level of X watches per week, our total weekly cost is C of X, and C of X can be given by this function that we've indicated right here. C of X is $50,000 plus 600X minus 0.75X squared. So that's the cost of producing X watches. Now, a reasonable question would be, how fast is this cost changing? So we could say, what would be the cost of producing 200 watches? Well, the cost would be C of 200 would be equal to 50,000 plus 600 times 200 minus 0.75 times 200 squared would be equal to, and I wrote that down, it's just a calculator problem, $140,000. So if we're producing 200 watches per week, our weekly cost of production is going to be $140,000. What would it cost to produce the 201st watch? Now be clear that you understand what we're asking here. We're not asking the cost of producing 201 watches. We're talking about how much cost would be added if I went from 200 watches per week to 201 watches per week. That is the cost, that would just be the cost of that one additional watch, the 201st watch. So what would that be? Well, this is very much like the work we did in the previous video. So it would be the delta C, which would be a function of what the cost function is and where we are on the cost function. We're at 200, we want to go to 201, and what the increment is, or the dx or the delta x, and that would be 1 unit of production in this case. And so from previous material, this would be C of 201 minus C of 200, and that would be equal to, and I did the arithmetic with my calculator, but it would be 299.25. that would be the exact cost of adding the 201st watch. But I mean, here's your cost function right here, and you can see that there was a little bit of computation in calculating this. I had a calculator, it wasn't difficult, but there were several steps. So is there a shortcut we can take to approximate this? And the answer is yes, we can, and we were going to talk about the marginal cost of the 201st watch. And that's a concept from economics, and they talk about the marginal cost, the marginal revenue, the marginal profit, and marginal. You can talk about the marginal anything, but the marginal cost is just equal to the derivative evaluated at x equal 200. So that would be the marginal cost of the 201st unit of production. It would be the derivative of the cost function evaluated at 200. Let's try out the marginal cost and see how that works for us. The first thing we'd have to do is to find c prime of x, but we've practiced finding derivatives for a while now. So we come up and we look at the derivative function, and by this time I think by inspection we can write down that that derivative would be 600 minus 1.5x, so that c prime of 200, the marginal cost for the 201st watch, or this would tell me how fast cost is increasing when I'm producing 200 watches. That would be equal to 600 minus 1.5 times x, where x is 200, would be 300. So this is the exact cost, and this is called the marginal cost of the 201st. C prime 200 tells me what the next unit of production is going to be. Now I want you to think of it this way. C prime of x, that's the marginal cost, would be equal to c prime x times 1. Now remember that in the previous work we found that delta C would be approximately equal to dC using the differentials, and dC would be equal to c prime x dx, where this was the amount of change we were talking about. Well, in this case we're talking about the next unit. We're talking about dx of 1, and if dx, if you're talking about the next unit of change, then we have that delta C is approximately equal to C prime of x. And that's how we use the marginal anything, the marginal cost, the marginal profit, the marginal revenue. All right, so just one more example and then we're going to wrap this. And so let's suppose that, for emphasis here, we'll go to a different color. Suppose that we have a profit function and that's P of x, and it's equal to 8x minus 0.001 x squared minus 7,000. Then I'm going to ask you, what's the profit at a production level of 1,000 units. Well, you know that this would be P of 1,000 would be equal to, and again I did the arithmetic beforehand, would be equal to $6,000. And so if we're producing 1,000 units, then the profit when we unload those 1,000 units, according to this profit function, would be $6,000. What's the profit on unit number 1001? Is it worth adding another unit? What would the profit on that 1,001st unit be? Well, the exact answer, which we may not want to calculate every day, but the exact answer would be P of 1001 minus P of 1,000 is equal to $5, and I'm going to put 3 nines there for emphasis. So that is the profit on the 1,001st unit. If I go from 1,000 units of production to 1,001, I'll make another $5.999. Now, what would the approximation be, the marginal? Oops, not cost, but profit. Well, the marginal profit would be P prime of 1,000 would be equal to, you'll have to take the derivative here to get P prime, but I'm going to let you do that and see if you agree that the marginal profit at 1,000 is $6. So we'd want to compare these two values, and we see that in fact the margin is pretty close to the delta P. All right, so the marginal, it's a concept that is used a lot in economics and in business, and it's as simple as that. Thank you, and have a good day.